Let us consider n independent trials of an experiment. For example, tossing a coin n times. And now in each toss it gives rise to a head or a tail. Now head, suppose occurrence of head we treat it as a success, and these trials are all independent in the sense that chance of getting a success in a particular trial remains the same in all the trials. That doesn't change with any number of trials you conduct of that experiment, that is tossing a coin. The probability of success remains the same, that is getting a head remains the same. Now that is one example where we have n independent trials. These such trials we call as Bernoulli trials. What are Bernoulli trials? N independent trials wherein some group of outcomes in a particular trial are branded as success and other group of outcomes are branded as failure, and the probability of success remains to be same in every trial of the experiment. Okay. So n independent trials, let P denote the probability of success in a trial let capital X denote the random variable which counts the number of successes out of n trials So when we go for say 5 trials, it is possible that in all the 5 trials I get a success, or I may get success on the 4 trials, 3 trials, 2 trials, 0, 1, 0. So the range of x is 0, 1, 2, so on up to n. When I say probability distribution, we have to give a random variable. We have given a random variable. Now corresponding to each value of the random variable, some non-negative number has to be attached so that the sum of all those non-negative numbers is equal to 1. That will be the probability distribution. We define probability of x equal to some r being the number of successes, to be NCR p power r into 1 minus p to the power n minus r. At times it will be convenient to write 1 minus p as q, and therefore this turns out to be NCR into p power r into q power of n minus r. So what is q? Q denotes the probability of failure in a particular trial. Now r ranges from 0, 1, 2, so on up to n. It's very clear that this indeed is the probability distribution. That is, when I add up, these are all non-negative numbers. NCR is a counting number. P power r, P is the probability of success, we said. So P has to be definitely positive. So 1 minus P, that is Q, that is also positive. Right. Probability of failure, that also has to be a positive quantity. P power r, positive quantity. Q power n minus r, positive quantity. So it is, to each value of the random variable we are attaching a probability which is going to be a positive quantity. Now when you add up all this, you must get 1. Let's see if we are getting 1 or not. What is the sigma of, this is PR, let us say, what is sigma of PR? R ranging from 0 to n. That is sigma NCR p power r into q power n minus r, r ranging from 0 to n. That we know from binomial theorem, that is nothing but q plus p power n. What is q plus p but 1? So 1 power n is equal to 1, and therefore we have verified that this indeed is a probability this attaches probability corresponding to each value of the random variable. It does give rise to a probability distribution. So how does a binomial probability distribution arise? When you have n independent trials of an experiment, and in each trial we have only two types of outcomes. That is, some group of outcomes we brand them as X, S, success. Other group of outcomes, complementary group of outcomes, we brand them as failure. The probability of success is assumed to be constant for in every trial of the experiment. Okay, so in a trial, then probability of failure also becomes constant. What is the probability that the random variable which counts the number of successes is equal to R? That is NCR into p power R into 1 minus p to the power n minus R. We will just take up a problem now. A coin is tossed five times. Find the probability that at least two heads appear. Two heads appear. Okay, so we have a coin which is tossed five times on the first five different occasions. Whatever is outcome, I'm going to put it in these five boxes: second, third, fourth, fifth. Clearly there will be 2 power 5 outcomes. Now let X denote the number of heads. X is a random variable which counts the number of heads. Now getting ahead is a success. Number of heads or number of successes. So getting ahead, we'll treat it as a success. How many trials are made? 5 trials. So n is 5. Now it appears to be a case of binomial probability distribution. So what is being asked? Probability of the number of heads being is at least 2. So probability of X taking a value greater than or equal to 2. What is the range of X? Range of X is 0, 1, 2, 3, 4 up to 5. 4, 5. 0, 1, 2, 3, 4, 5. So corresponding to each values of the random variable, we know the probability of X equal to R to be equal to 5CR half power. What is the probability of success? Assuming that the coin is an unbiased coin, nothing mentioned we should take it to be an unbiased coin. The probability of success and failure in a particular, getting ahead is a success, we said. So probability of getting ahead is half. So in a particular trial is half. So half power R into 1 minus half power 5 minus R. That is R for each R ranging from 0, 1, 2, so on, 3, 4, 5. Now what is it we are required in the problem? Probability of X greater than or equal to 2. So what is that? Probability of X equal to 2 plus probability of X equal to 3, probability of X equal to 4, so on. You can add up all these probabilities because these are mutually exclusive events and you can add up the probabilities. It's a union of 4 mutually exclusive events. Instead, we can even go by the complement. Probability of X greater than or equal to 2 will be 1 minus the probability of these two events. Probability of X equal to 0 plus probability of X equal to 1. So what is the probability of X equal to 0 and probability of X equal to 1? I would have got this way: 1 minus 5C0 by 2 power 1 by 2 power 5 into 1 by 2 power 5, and then 5C1 into 1 by 2 power 5. So that is what we have here. That turns out to be 1 minus 5 plus 1, 6 by 2 power 5, that is 1 minus 6 by 32, that is 26 by 32 there. Okay, so that is further 13 by 18. So that's the probability, required probability. Let us consider an example problem wherein we can use a binomial probability distribution. Look at this problem. I take a step forward with a probability 0.45 and backward with a probability 0.55. What is the probability after after 13 steps I am 3 steps away from the starting point? For example, I am standing in front of you here. So if I move 2 steps and then move forward 2 steps and move backward 3 steps, so effectively I'm 1 step away from the starting point. The total number of steps that have to be taken is 13, and the person, I have to be only 3 steps away from the starting point. So some forward steps and some backward steps have been made. So x number of forward steps and y number of backward steps have made, so that x plus y is 13 and x minus y is equal to 3, because you're saying that you're just 3 steps away. We have to be 3 steps away from the starting point. So the number of steps may be forward steps, let me call it as F, backward steps, let me call it as B. This could have been 8 and 5. So if I had made 8 forward steps and then move back in some order, total is 8. Okay, and the total number of backward steps I have taken is 5, then I would have been effectively at 3 steps in the forward direction from the starting point. Or I could have made 5 steps forward and 8 steps backward in some order. So in each case, I am just 3 steps away from the starting point. But then, what is the probability that out of the 13 steps, I will be making 8 forward steps and 5 backward steps? It's like this. It is a case of a binomial distribution wherein the number of trials is taking a step. Number of steps I am taking, n is 13, and success is moving forward. So in each trial is like taking a step, and success in a trial is moving forward, a failure is moving backward. Let us say, so out of 13 trials, 8 successes and 5 failures. Okay, so this I'll say 8 successes and 5 failures. 5 successes and 8 failures. Corresponding probability, what is it? Let's go with the formula. 13C8. I take a forward step with what probability? 0.45. So probability of success in every trial, that is at every step, whenever I am a particular position, the chance of moving forward is 0.45. So 0.45 raised to the power 8 into 0.55 raised to the power 5. Or the number of forward steps, backward steps can be 5 forward and 8 backward. So in that case also we will be just 3 steps away from the starting point. That is going to be 13C5 into 0.45 raised to the power 5 into 0.55 raised to the power 8. So your event of being at a stage of just 3 steps away from the starting point could have happened either this way or this way. So we got to add up these 2 probabilities. The required probability will be sum of these 2. 13C8 and 13C5 are one and the same, so let me take it as 13C5. 0.45 raised to the power 5 0.45 into 0.55, whole thing raised to the power 5, that's common. And now you have 0.45 cube plus 0.55 cube. Okay, so this is the required probability.